Hello everyone. Today I'm going to be teaching you about the ideal gas law. So ideal gas law can be explained as the equation PV equals nRT. Okay. And the P stands for pressure, V stands for volume, N stands for number of moles. R is our constant to mitigate for whatever value of pressure we choose. We can have atmosphere, torr, kilopascals, and temperature is going to always be in the unit Kelvin. Okay, so to first kind of understand the relationship between all these variables, we first need to understand Boyle's law, Monton's law, and Avogadro's law. So Boyle's law states that pressure is inversely proportional to volume, right? So as the pressure of a gas increases, the volume is going to decrease. Okay, and vice versa. If the volume increases, the pressure is going to decrease. Monton's law states that pressure is directly proportional to temperature. So as the temperature of a gas increases, the pressure is also going to increase. So this makes sense because remember how temperature increases, increased temperature causes gas molecules to move faster because they have more kinetic energy. And that's going to cause more collisions against the container of whatever container the gas is in. And because pressure is the amount of collisions of gas molecules against the container in a given time, it's going to increase pressure. So increased temperature, increased pressure. And then our last law, Avogadro's law, basically states that number of moles is proportional to pressure. So if we increase the number of moles of a gas, we're going to be increasing the pressure. This makes sense because the more gas molecules you have, the more molecules are going to be colliding with the walls of the container, therefore pressure is going to increase. Okay. So now that we understand the relationship between the two, remember that P and V are going to be on the same side because in this equation right here, if we times both sides by volume, we get PV equals 1. And if we have, kind of just to further illustrate that, if PV equals 8, and we can assume that, say, if V is 4 and P is 2, if we're going to increase P to 4, well, then we need to decrease V to 2 so that we have the same, right? So that's why you have these on this side. And N and T are going to be on this side because they are equal, or they are going to have a direct increase on pressure. And then for our R value, if we use atmosphere, we're going to use 0.08206, which is going to have the units liters per atmosphere over moles times Kelvin. And we're only going to be using atmospheres in these examples. So if we look at this first problem, a balloon has 2.5 moles of helium gas. The temperature is 293 degrees Kelvin, and the pressure is 1 atmosphere. What is the volume of the gas in the balloon? So if we look at our equation, PV equals nRT. We have moles, right? 3.5 moles. We have the temperature in Kelvin, so we don't need to do any conversion there. And then we have our atmosphere. So 1 atm equals 3.5 moles. And then we have our R value as well, right? So 0.08206. And then we have Kelvin, 293 degrees Kelvin. All right, and then what we want to find is the volume of the gas, so it's going to be in liters, okay? So if we want to find volume, we can just divide both sides by P, to where we have volume equals nRT over pressure. All right, so let's begin to solve this. So we're going to put 3.5 moles times 0.08206 And the units again are liters per atmosphere over moles per Kelvin. Then we're gonna have 293 degrees Kelvin. And that's all over 1 atmosphere. And that's gonna equal our pressure. So if we begin to multiply this, we can cancel moles. Okay, we can cancel atmospheres, cancel kelvins. If we add these all together or multiply these all together, we are going to get liters. Oh, sorry, I said 3.5. It's 2.5. So we get 60, and when we don't divide it by 1, just gets us the same answer. So we get 60, and we can just round to 60 because of sig figs. So 60 liters. Volume equals 60 liters. All right? So now we're gonna look at our next example. How many moles of air are in a bicycle tire if it has 3.8 atmospheres of pressure, a volume of 2.1 liters, and is at a temperature of 15 degrees Celsius? Okay, so the first thing we need to do here is convert our temperature from 15 degrees Celsius to units of Kelvin. So the conversion factor for this is going to be plus 273.15. So yeah, that times 15, and we get 288.15, right? And so to set up this equation, we need to look at what we're solving for and what we already have. So we have atmosphere, we have liters, we have our temperature in Kelvin now. And because it's in atmospheres, we're going to be using 0.08206 as our R value again. And we need to figure out how many moles of air we have in the bicycle tire. So if we have PV equals nRT, we're solving for moles, so we can divide both sides by RT. And that gets us PV divided by RT equals N. So that's what we're going to be solving for. So let's set that up. So 3.8 atmospheres times 2.1 liters over 0.08206 liters per atmosphere over moles per Kelvin times 288.15 equals N. So we cancel out atmosphere, liters, and Kelvin. Just forgot to put Kelvin right there. Kelvin goes right there. And if we multiply those all, 0.8 times 2.1, 7.98. So this is going to equal 7.98. It's going to be over 23.64559. Okay, so if we divide this, 7.98 divided by 23.64559, we get about 0.3 0.375. And if we look at our sig figs, we can just round it as 0.34 moles. So N equals 0.34 moles. So that is my little instruction video on how to work problems with the ideal gas law.